Hello everybody, today I present an abstract entitled Emotion Recognition Using EEG Signal, Accuracy Comparison Between Methods and Frequency Bands. First, let's review the presentation procedure. At the beginning, we will talk about social robotics and emotion recognition and EEG signals. Then methods and materials which used in this research will be discussed and results come after them. At the end of the presentation, I'll talk about outcome of this article and future works. This abstract is a part of my master thesis. My thesis involves two fields of science, BCI and social robotics. In my thesis, the goal is to identify a person's emotion using EEG and then interaction of a social robot with humans based on identified emotion state. Today, I want to present the results of emotion recognition section in this presentation. A wide variety of definitions and categorizations have been proposed in the field of emotion. Emotions are usually categorized into two methods, discrete and dimensional models. Discrete modeling categorizes emotions into discrete states such as happiness, sadness, fears, or etc. While dimensional modeling describes emotion using their underlying dimensions. For example, a rating to determine the amount of valence and arousal. Valence exhibits how a human has a pleasant feeling, and arousal shows amount of excitement. There's a connection between these two methods. For example, a pleasant and an exciting event shows a happy feelings. So it's a connection between two methods. Okay, now we describe methods used in this research. First of all, graph neural network or GNN summarizing will be discussed in this slide and next. A GNN is a classic network which in the first layer has a graph. GNN structure can be considered in two general parts. Um, the first part is a graph that receives data and converts them to the input for the second part. I hear something. Huh, okay. Is there any problem? Okay, sorry. Uh,
Uh, we can see your screen. Maybe some other people cannot.
okay,
If
okay, okay. I
it's
go on.
screen, yeah, we can see yours.
Okay. I'm describing GNN. GNN is a classic network which is in the first layer has a graph. GNN structure can be considered in two parts. A first layer as a graph and a second part as a simple MLP. First graph layer is in GNN gives them ability to find the relationship between inputs. And in our research, these nodes in the first layer graph are the EEG cap electrodes. It could be very helpful to find the relation between EEG cap electrodes and regions of the brain. Now we take a fast look on what happens in the first layer. There are three main steps in first layer. Each node that in our research are the electrodes of EEG cap take their inputs and after performing a nonlinear transformation, send them to their neighbors. Every neighbor node receives information and then perform a linear mapping and summarize all received data and self-esteem. Summarize mapping usually is a simple summation. After sending data, each node has its previous state and all data from its neighbors. And based on these information, generate output. And then output sent to the second part, MLP that described in the last slide. In this research, we used Ascertain dataset. The Ascertain is public dataset published by Wage and al. This dataset contains psychological response of 58 users while viewing 36 affective movie clips. Ascertain is a multimodal dataset. This dataset contains EEG, ECG, GCR, and emotional self-ratings of users. In this study, we just used EEG signals and emotional self-rate states for emotion recognition. Statistical features in time domain in all frequency bands reported in dataset, and 8-channel dry electrode EEG device was used for data acquisition. There are three main goals for this research. Researchers who published a certain dataset classified emotion into two classes based on self-ratings that exist in dataset, arousal and valence classes. They used SVM and naive-Bayes classifier to do binary classification. First goal of this research was designing and performing a GNN for a binary classification and comparing results with previous results. In addition, in this study, we divide ascertained dataset into four classes. If H means high, L means low, V means valence, and A means arousal, these four classes are HAHV, HALV, LAHV, and LALV. In the arousal and valence play, there are four regions, and we want to classify all datasets into these four classes. As a third goal of this research, we investigate the effect of frequency band selection on the accuracy of emotion recognition. K-nearest neighbor, support vector machine, decision tree, and discriminantal analysis, and naive-Bayes have been used to classify dataset into four classes. These classifiers have many types and algorithms. For SVM, we just applied a linear and Gaussian kernel. In the KNN algorithm, there are many choices to define distance function, and we used CT-block, Chebyshev, correlation, and Euclidean. For naive-Bayes, we just used Gaussian naive-Bayes, and also we used linear and quadratic DA. Sorry for a second. So sorry. Um, and where were we? And to obtain the best average accuracy, the implemented MLP and GNN were run by considering different hidden layers and two hidden layers selected. All the methods' accuracy were calculated using the k-fold cross-validation. Due to this dataset isn't a big, because we used cross-fold validation to use all data for training and testing. For EEG signals, there are main groups of features: time domain, frequency domain, and time frequency domain. We just use time domains, and we use features mean, standard deviation, skewness, and cortices. And we want to compare accuracy of various methods and also compare accuracy of various frequency bands. To find accuracy of a specific classifier, we calculate accuracy by using 5 frequency bands separately and together, totally 6 possible modes, and then an average of these 6 modes reported as accuracy of one classifier. Also, to find accuracy of a specific frequency band, we got the average from accuracies of all classifiers which used that frequency band. For example, to determine the alpha band accuracy, we used this band as input of all classifiers and then got the average on the accuracies. This figure compares all resulted accuracies in 4-class classification using classic classifier. Chance level is 25% because there are 4 classes. Results in this slide and following the slides reported separately for each frequency band and each classifier. As you can see, the quadratic DA has the greatest accuracy in all bands. And this figure shows accuracy comparison between MLP and GNN that we used for binary classification. We implemented MLP to show how GNN could be productive and good in emotion recognition. Chance level in this figure is 50%. It's obvious that the accuracy of GNN overall is 20% greater than the MLP almost in all bands. It seems MLP is totally inappropriate for this application. And finally, this figure shows accuracy dependency with frequency band selection. As mentioned before, these accuracies determined by averaging over all methods of classification. We had the three main goals for this study, and so we have three main conclusions. By performing various types of classifier, it was concluded that quadratic DA classifier has the highest accuracy. By implemented the GNN, by implementing the GNN, an average accuracy of 68.71 was achieved for binary classification, which is approximately 10% higher than accuracy reported previously in ascertained dataset, and also greater than the accuracy of implemented MLP in this research. According to the findings of this research, the alpha and theta bands contains the most information about emotion. The accuracy of emotional state detection using these two bands, alpha and theta, is even higher than the accuracy of detection when we use all frequency bands. It should be noted only time features have been used in this study. And because the cost of computing and the time required to train the network are important in large data set, the optimal choice of frequency band is important because it speeds up the performance and reduce the latency of the algorithm in real-time emotion recognition, which I have to use for my thesis. For the future works, we have four main plans. First of all, to find out GNN is a suitable for emotion recognition. We have plans to perform this network on the other and bigger data set, such as SEED. And also, we want to investigate accuracy dependency with feature selection. We want to use other types of features such as frequency domain and time frequency domain for emotion recognition. Based on our knowledge for online emotion recognition, with EEG signals, we should use time frequency domain features. Ultimate goal of this research is using of a emotion recognition system to detecting a human emotional state and then sending this mode to a social robot, and then social robot interacts with the human based on his emotional state. For example, if a human is sad and have a bad feeling, social robots makes him laugh and give him a good feelings. Thanks for your attention. I'm ready to answer your probable question.
Thank you very much, Mr. Nazemi, for your
You're
great
welcome.